Hello. Oh, I can't believe you mentioned my book. That's embarrassing. I'm going to also mention it. So a little bit about me. I've been doing Go for a long time, since before beta, actually. And I got into it because I wanted to build something on App Engine. And it was either Python, Java, or Go. And I didn't know any of them, so it was as good a choice as any. But I'm really glad I did. I wrote Go Programming Blueprints that little guy's holding there. It's a book where the only reason I talk about it, obviously, is because you build real projects with it. And Go is good at building real projects. And that's kind of, it has this reputation of being a little bit just like a systems geeky, systems low-level language. But actually, you can build a lot with it, real things. And I have. I'm working currently at GrayMeta.com, and we're exclusively Go. I also wrote a few little apps and things that are hosted and running on App Engine. So, you can run this stuff for real. When you put APIs and things in App Engine, by the way, the free quota is very generous, and but it's ready to fly when you're ready, or if a product takes off. So there's a few links there and stuff to check out, if you like. I also wrote Bitbar, so I don't know if anyone's. Don't cheer. OK. So what we're going to do now, then, is I'm going to teach you Go. Anyone? Who's heard of Go? OK, cool. And who's actually used Go? OK. So my aim is to convince you to give Go a try, especially when you want to build an API or build something, a real thing that you then are going to release into the wild. Go is different to other languages for a few reasons. The key one that stands out to me is its simplicity. It was deliberately cut down. It isn't bloated, full of language features. Quite the opposite. You'll notice a lot missing if you're used to Java, or I recently looked at Swift for iOS development, and the number of keywords in Swift is mind-blowing. There's a lot to learn. In Go, that's not the case. So there's very little magic. Everything you learn is their core principles, and you're applying those again and again to build real things. And you're kind of layering them up like that, rather than you have to learn something special for this case, and it's different in this context and all that stuff. There's also a standard format for code. And this is part of the toolchain, which means that all Go code kind of looks the same. And it has this strange effect where if you look in an open source project and you look at some code, you're not sure whether you wrote it or not, because it looks like code you write. So think about that. That gives you massive benefits when bringing people into a team or collaborating remotely or something. Just the fact that it looks and feels familiar. It is famous for its built-in concurrency, and it really is cool. Basically, they designed this language to make the most out of the architecture that you run it on. So it makes it really easy to use all the cores on the machine and really get the most out of it. And it isn't complicated. There are a couple of concepts to learn, and once you've got them, you can use them to build extremely highly performant things. Testing is also a first-class concern. Show of hands, who writes unit tests in their code? Awesome. Who writes unit tests first, i.e. test-driven development? OK, not so many. Well, either way, Go makes that possible. It's part of the tool chain from the beginning. The Go community is second to none. Really, really good, engaging, polite, which sounds obvious and simple, but lots of tech communities aren't those things. Go also compiles like lightning, like this, to a single binary. And that's a really nice thing to have because, sometimes you sat around waiting for things to compile and stuff. Well, that goes away with Go. And the standard library is very impressive, too. We already have HTTP2. There's some philosophical points that come along with Go. And it really keys around simplicity, keeping things simple. A lot of people focus on the cost of developing a thing in the first place. That seems to be how we think about the cost of a project. And we sort of ignore the maintenance over time. Well, really, the maintenance over time, if the project is successful, That's a way bigger number than the amount of time you spend just developing it initially. So, Go addresses that by remaining simple and familiar and easy to maintain. So here's some real Go code. For anyone that hasn't seen it, it looks a bit like C. You have pointers to objects, you have structures, you import things at the top. But a couple of things to notice. You don't have methods inside a class or something. Instead, in this case in the bottom, we have this greet method, and you give it a receiver. And what that does is it says this is essentially a function that operates on this structure. And what that means is, and you can see, we have the G argument. It's sort of arguments going before the method name. So there's no concept of self, which is another thing to learn. Instead, it's just another variable that you can use in the body. Go also lets you have multiple return arguments. And other languages do too, but what's nice about the pattern that seems to emerge through the standard library is that the second argument is an error. So errors aren't, again, there's nothing new to learn. It's just another return type. It could be nil. It probably will be, hopefully, which means no errors have occurred. If something does go wrong, that won't be nil, and you can check that, and you can deal with it. So to use this greeter class, I can just call my new greeter function. Notice that there's no constructor here. This is just a normal function. It's just a top-level global function that creates a greeter and initializes it for me. So I call that greeter. I specify a format, which is kept in the structure, and then I can call it many times. And if I run this code, you can see that it's quite easy. And I could tweak it and pass in a different format and say, hello there, name. Now, when I hit run on this, it's actually building all that code, compiling it, running the tests, and executing the main function. And you see how quick that is. And this isn't a particularly fast machine. That just is how fast Go is. You really get used to it. In fact, on save of any Go file, in our projects, we build the whole package, run all the tests, we format the code using the automated tool, we vet the code, and we do linting on it and stuff, and we do all that at the hit of a key press. So you hit save, and the window pops up with any issues. That's how it feels. But it's actually doing a lot in the background. Rob Pike, one of the founders of Go, at Gophercon said, it's not that Go's fast at compiling, it's that everything else is, for some reason, really slow at it. So he's very modest, but I think they've done a good job when it comes to compile times. Go is too cool for just a 30-minute talk about it. But just to give you a little taste of some of the things you can do with Go, there's a keyword called Go, which you then call a function. It runs that function in the background. So that's how you do multi-threading in Go. It's 3 key presses, G-O space. And Go routines are cheap. Go routines are what kick off and do background work for you. In this code, I can start 10,000 of these things. They're going to run this function. It just does it. And when it comes to communicating, that's when normally in multi-threaded code it gets really complicated when you want to share memory or try and have these things cooperate. Well, Go brings in channels as a first-class type. You can make a channel and have 2 or many Go routines communicate through that channel, and the communication's guaranteed to be safe. So you don't share memory, you communicate. And that's a slightly different way of thinking about it, but what it does is it makes writing really high-performance code. It makes it really simple. You can do other things too with channels, like you can use them for signaling and closing. And here's an example select block, which is waiting for different things to happen on different channels, and then also waiting for a timeout at the bottom there. And and all of that stuff happens safely. Only one of those cases will run at any one time. So you're free to modify shared memory in these cases if you want to. So I really want to talk about building APIs in Go, because Go really this is where it really shines, because it's so easy to do. The HTTP package in the standard library gives you a few types, and actually, it's really everything you need in order to deal with HTTP. But the simplest types that it has this interface called handler. And interfaces in Go aren't implemented explicitly. They're almost like duck-typed. They're implicit. It's called structural typing, in fact, because it's not a runtime thing. It happens at compile time. So you still get all that type safety. But any object, any structure that implements serve HTTP with this signature is a handler and can be used to handle requests. So then we use the handle method to map it to a path, and that's kind of it. We also have a handler func, which is it's a function type alternative to the HTTP handler. And it works in an the result of it is you can just use the function that looks like the right signature. And you don't even have to build objects. You can just have functions that are handlers, which is cool. But how it works really highlights something about Go, which is just with a few simple things, you can actually get some quite staggering results. A handler func is it's a function type, and there's the code for it. So it's literally, you're saying, this is the type, and it's a function that matches this signature. Then there's a method on that function called serve HTTP, which implements the HTTP handler interface. So what's happening there is the handler func, this method gets called since it implements HTTP handler, and all that does is just calls the function itself here. So it's a little bit odd when you first see it, but really powerful and really starts to show off some of the benefits of particularly single method interfaces, which happen throughout the standard library, and they're all really powerful. So here's a real production-ready program. It's a very simple one. It's an API it's a JSON API. When you do a get on /hello, it returns a JSON object with a message that says hello Infoshare in it. And I haven't shrunk that for effect. I mean, that really is what Go code looks like. Maybe you wouldn't have the function in line, but maybe you would. I mean, it's simple. Why complicate it? If you have 10 of these, you might decide, OK, I'm going to pull them out and have them so that the functions are just standalone, and I'll map them. Awesome. But there's no need to overcomplicate too soon, and that's another kind of philosophy of Go. The HTTP response writer is everything you need to give a response to a client. So you have headers that you can access. You can write bytes down to the client, and you can write the header with a status code. I mean, and that's really it. That gives you everything you need to deal with HTTP clients. And the request, of course, contains everything you need to know about the request: the body, the path, URL parameters, that kind of stuff. So middleware is an interesting thing. This is the idea of doing something before and after, or your handlers actually run. So in this example, we have a log function that takes in a handler and returns a handler. So it's kind of an adapter pattern or a decorator pattern. And using handler func, we can just return we can just use a function to represent a handler, as we said. So in this case, I'm returning this function, which will do something before the handler runs, maybe log some information about the request. Then it calls serve HTTP on the handler underneath it. And then it can do something after the handler, like log information about the response. You can take that one step further and actually create a middleware type. And the middleware type is another function type, and it's a function that takes a handler, returns a handler, so it's one of these adapters. But then you can create a function like logging, where we're going to say, I'm going to do logging, and I'm going to log to a specific type or to a specific object. And then this is, by the way, the most complicated Go code ever gets. So we have a logger here. It returns a function, which is a middleware function. And using closures, it captures that logger, that state, and then it might do the same kind of behavior as before, logging before and after. So to use it, you just say with logs equals logging, pass in the logger, and that with logs is a function that gets returned, because middleware, the type middleware is a function. We then call with logs on our handlers, and we're able to adapt those so that the logging happens to that logger. And look how simple the code is where we actually use it. We took on a bit of a pain with the complexity in defining it, but when it comes to using that, it's kind of trivial. And easy to read. I mean, any programmer, if they'd not even seen Go before, particularly this use stamp at the bottom, if I said what's happening there, it's kind of really obvious, I think. We this morning had a workshop, and it says 3.5 hours here, but it's actually 3 hours. We built a complete API from scratch and hosted it on App Engine. We've put the code there, github.com/mattryer/infoshare. And it's a comments API, so quite simple. Post to add comments and gets to read comments. But the interesting thing is we keyed it on the URL, so you can actually. It's an API that lets you discuss websites or web pages, URLs. So you could use it for if it's on Amazon, you could discuss the product. If it's on eBay, you might do something similar. If it's an article about something else, you could actually have a conversation around that. So quite a simple API, but one that could form the basis of something much bigger. And we put it on App Engine because we get that free quota, but we also get the ability to scale when the time's right. You get this too with Python and Java on App Engine. So one line to deploy the app and get it live, which you can see. There's links to it on that GitHub thing. And then once it's live, it's kind of the instances are managed by Google, and they are ready to scale. And you have the free quota is quite generous. So often for small apps, you'll never have to pay anything. If your API or whatever it is, your product gets more successful and you start peaking over the quota, then of course you start paying something. But of course, at that point, you've got yourself a hit, and you don't mind paying it. A little bit on the community. Looking around the room, I noticed that, and actually in the tech everywhere I go and meet people, it's a very male-dominated world for some reason, and I genuinely don't know why that is. Something's happening. So one of the things the Go community tries to do is include as many people as possible, because of course, the more people we have involved, the better it's going to be for everyone. So great. There's a group called Women Who Go, and you can check that out. So if there's any women that are interested in Go, there's actually a dedicated group for that, which is kind of, well, they're growing all the time, and it's really great to see. And then generally you have meetups everywhere. There's a good Slack channel where we can get on, talk about stuff. And I encourage everyone to get involved and have a play and build something. And you'll be surprised, I think, how well and how quick you can build these things. Ruby on Rails had the kind of achievement for being the rapid web development technology, and it was definitely, it was awesome and is. But what Go gives you is it's much simpler and there's much less magic. So in Rails, and this is true for any kind of framework, if it isn't doing quite what you want it to do, it's a nightmare. It's all great while it's just doing authentication and we don't care. As soon as the designer comes and says, oh, well, we're not going to do sign in with Facebook now. We want to do this other thing instead. Well, this framework doesn't support that, so now we're kind of stuck. And often product decisions are made because of the resistance, and the difficulty in the technology, which isn't insane, but it's a shame. It can be. So within Rails, whenever it didn't do the thing you quite wanted it to, it became quite difficult to coerce it to do that, I found. And Go, by kind of stripping it all back, means you have these basic things to work with to build up just what you need in the right way, and you don't get any kind of waste or behaviors decided for you by somebody else. Go does have some really cool packages that have been done. There's a MongoDB driver, for example, which is awesome. And of course, you would use that. You wouldn't write your own MongoDB driver. It does exactly what you need, probably. It's, the higher up the stack you get, that's when you have to start making decisions as a programmer. And those sorts of packages can be quite tricky to work around if you don't want to. And that's it. Thank you very much. I think I'm a little bit early.
Thank you, Matt. I have one question from the public. Because Go is quite a young language, is it ready for production?
Sorry?
Because Go is quite a young language.
Yeah.
Is it ready for production?
Right. Yes. Someone asked this as well in the workshop this morning. Because Go is quite young and new, is it ready for something to be out there in the wild in production? Well, the answer is it is in production in lots of places. Docker and Kubernetes is all written in Go. SoundCloud use it quite a lot. There's a bank in London called Mondo that are building exclusively in Go, and it's the perfect bank. It's APIs, it's everything you want from a bank. It's like payments that go through immediately, things like that, So yeah, the answer is yes. People are using it in production. We are at GrayMeta. It's ready to go, and that's what I want to see more of that. I want to see more people using Go.
Okay, thank you, Kevin. If you'd like to ask Kevin some additional questions, he will be available after a short break. Thank you.
Yes, and me as well. I'll be with Kevin.
Oh, sorry, Matt.
Yeah,
sorry. It's been a long
Kevin.
day.
Thank you. That's all right.